What we're going to do here is confidence intervals, and as you probably can guess, is to do with single sample proportions. Okay, so we have one sample here, and the sample size is 100, and essentially what we've done is performed an experiment, and what we're interested in is how many successes there were, and so on. So suppose we have 70 successes in 100 trials of an experiment. So compute the point estimate. I sort of made this sort of deliberately vague just to sort of more so get people used to the terminology, and the corresponding 95% confidence interval. Well, the point estimate is the sample proportion, okay, and we're going to denote it p hat, and it's essentially the number of successes over the number of trials. So it's x is the number of successes, n is the number of trials, so p hat equals 70 over 100, 0.70. Okay, so that's all. And again, x is number of successes, n is the sample size, okay, for this single sample, and we're only dealing with one sample. Now, the confidence interval is the tricky part. Well, not the tricky part. 95% confidence interval. Okay. Now, it is supposed that you've learned a little bit about confidence intervals already, that you have done single sample means. Okay. But a general quick run through of it is the point estimate, which we know, plus or minus quantile times the standard error. Okay. Now, just as a remark, we have the point estimate already is p hat. That's our point estimate, and that is 0.70. Now, the quantile. I'm not going to do too much in the quantile in this video. Just suffice to say, it's a large sample. That the sample size is greater than 30. You would usually tend to get large samples in these sort of with proportions. The whole small sample size thing usually comes with when you're dealing with means, sample means. But it's a 95% confidence interval. Okay. And it's a large sample size. So essentially, I'm going to just sort of state here that the quantile is 1.96. And if you're unfamiliar with how I got that, I think you just need to sort of go back to some of my earlier videos. It's for large samples, it's always the quantile for a 95% confidence interval. Now, the last part, the standard error. Okay, so this is the sort of general structure for a confidence interval. Okay. No matter what type of interval you're working with, they always follow this sort of structure. So you just have to sort of amend it each time. So we have the point estimate, the quantile. So all we have to do now is calculate the standard error. Okay, the standard error. Now, particularly with proportions, be very, very careful about the standard error. Because you probably haven't come to hypothesis testing yet, but it can actually change depending on whether or not it's a confidence interval or a hypothesis test. This is for single sample proportions. So for single sample proportions, the confidence interval standard error is p hat times 1 minus p hat all over n. Okay, so what we have here is 0.7, that's p hat, times 1 minus p hat is 0.30. So 0.30 all over the sample size, which is 100. Okay, so this is just essentially a little bit of calculator work. Okay. And essentially what we do here is 0.70. So just be very careful, particularly as you're about to get the square root of this. So do this several times on your calculator and just double check your answer. what you should get is 0.21 divided by 100. Okay, so that's 0.21 divided by 100, and that is equal to the square root of 0.0021. Okay, and when you get the square root of that, you can keep it to a couple of decimal places. I'm going to sort of keep it to 0.0458. That'll do. I'm going to just keep work to 4 decimal places. 4 is enough. Okay, so that's the standard error. We might properly denote it. Standard error of p hat equals 0.0458. Okay, now, so let's put it all together. Our confidence interval is p hat, I'll just start again down here, p hat plus or minus the quantile, so it's 1.96 times the standard error for p hat. Okay, and that is 0.70 plus or minus 1.96 times 0.0458. Okay. Now, actually, just as a quick remark, we might actually know the combination of the multiple of these two terms as the margin of error collectively. Okay. So, working that out, and again, I'm going to just immediately put it to 4 decimal places. Is the answer there is 0.70 plus or minus. Working that out, the margin of error should be 0.0898. Okay, you could go a little bit further with it, but I'm just going to sort of leave it to 4 decimal places. So essentially what we have here is just 2 numbers here. So the first one is 0.70 minus that, or 0.70 minus that term. We would have 0.6102 and 78 or 0.7898. Okay, so that's the answer there. That is the confidence interval that we're looking for. The main thing there is the standard error. That's the tricky part of this one. The quantile is tricky enough too, but it's not really. It sort of applies across the board, not just specifically to this one, this particular video. P hat times 1 minus p hat all over n. And yeah, that's it. So we'll leave it there.